Good evening, everyone, and welcome to Fun with 3D Assembly Modeling webinar. So, in this webinar, we are already have many webinars in this series, and this is the fifth one. So, in this webinar, I will be your guide, and I will be showing you how you can do assembly design in X Design. So first, let me introduce myself. My name is Rahul Rai, and currently I am working as a learning experience expert in Dassault Systems, and I have expertise in 3D design, X design, and SolidWorks design, and I have an experience of 7+ year in CAD CA training. And the goal of this webinar is to help you master X design through practical hands-on learning. And you can contact me on rahul.rai@3ds.com. So if you have any query related to X design, be it 3D modeling or assembly design, you can contact me and my teammates Sagar, Ishwar, and Rishikesh. So first, let's go through the agenda of today's webinar. So first, we will be having a quick recap of the previous sessions, and then we will know what is assembly and how you can create and open an assembly in XDesign. And then we will see how you can import the parts in assembly. And then we will know about mates and the type of mates. And then we will see few hands-on challenges. And then we can recap everything, and then we will see what are the next steps. So first, let's do the quick recap. So in the previous sessions, we have covered what is XDesign, and we have covered that how you can open XDesign, you can create a new part in it, and then how you can save those parts in XDesign. And then we have also explored about the basic sketch tools and commands like line, arcs, and circles. So how you can create those, and after creating those sketches, how you can extrude them to create a 3D model. And in one of the sessions, we also covered how you can create polygons, fillets, chamfers, and how you can use convert entities tool to create more advanced sketches. And then how we can use sketch mirror and sketch pattern to create duplicate entities in sketches. And then how we can create those in 3D model. So we also covered advanced modeling techniques like extrude cut, extrude revolve, sweep, and we also added chamfers, mirrors, and patterns in 3D models. So that was a quick recap of our previous sessions. And now let's see what is an assembly. So an assembly is a collection of multiple parts which are brought together in a single design. So as you can see in this picture that so this is not a solid body. There are multiple parts in it. So you can see that the brown part, there is a yellow part, and there is a handle in gray color. So all of these are created separately and they are brought together to create this complete assembly. So an assembly, it also defines how the parts will fit related to each other. So in a solid model, in a rigid body, nothing moves. But in an assembly, you can combine components and they will move according to fixed rules. So those rules are defined by mates. And when you create an assembly, that assembly actually mimics the real life functionality of that product. So suppose you want to create a tire, a robot, and in that robot there will be an arm, there will be some tires, there will be other moving parts. So to visualize how those parts will interact in real life, you can create an assembly. You will create each parts which will be moving related to each other separately. Then you can then assemble them, and then you can visualize how our parts will move in real life in the X design. So as I mentioned that how the parts will move according to each other will be defined using some rules which are called mates. So let's see what are mates. So mates are used to remove the degree of freedom. So any component in real world can move in X, Y, and Z direction. And similarly, it can also rotate about its relative axes, X, Y, and Z. So suppose I want something to move in only one direction, suppose in X direction. So I can constrain their movement in Y and Z direction so that it will only move in X direction. And similarly, we can arrange multiple parts and remove their degree of freedom. So that's how mates constrain the motion of parts in few degrees of freedom. And also they are also used to define the position and orientation of parts. So in this one, you can see that the handle is positioned on that brown plate. So that is also defined by mates. And so as I mentioned, that mates are used to replicate the real world joints, mechanical joints, or other kind of motions. So that's how they simulate the real world connections. And you can quickly create them by selecting two faces which you want to mate. So we will quickly see these in action in XDesign with our design challenge. So there are many types of mates. There are angle mates, there are concentric mates, coincident distance. So I will quickly jump into XDesign and I will show you how these type of mates simulate the real world phenomena in XDesign. So we will be providing you a zip called challenges. So you can just extract those. Right now you don't need to follow. I will just showing you how you can do it later. So in challenges there are multiple assemblies. So first I will show you that how you can import your parts in XDesign. Yeah, so first we will open your tenant. So in the tenant, you need to go to your uh, Made in 3D dashboard. There you can find the XDesign tab, and there you can start working in XDesign. So first you need to create a new part. So just like you create a part, to create an assembly also, you need to create a new physical product. So when you create a new physical product, so let me just refresh this tab because it was open for a long time. So sometimes that connection get lost. So that's why there is nothing on the left side. So I will just refresh this and get my connection back. So whenever you face these kind of issue that XDesign is behaving a little bit different, just try to refresh your page. Give it few more seconds and yes. So now XDesign has been loaded in your web browser. So again, so just like we create a new part, to also create an assembly, we need to click on create and then we can name it as a new assembly, or you can name it as the product that you are creating. And then you need to select the collaborative space. Right now I'm selecting this one and then click OK. So now you have created an empty part. So either you can create a part in it, or if you want to import your parts into XDesign, so then you need to upload those in the 3D drive. So here in the content tab, when you click on it, the 3D drive will be opened, and there you can just drag and drop and upload your content on the 3D drive. Yeah. So it will take a minute to get loaded. Yeah, so now it is here. So what you need to do, you need to open your Windows Explorer and all the folders which you have, you just need to drag and drop those in the 3D drive, and all of those will be uploaded here. So you can see the progress here and it will start soon. So that's how you can upload all of your components. Once they are in 3D drive, they will look something like this. Let me just quickly check. Yeah, so now they are all, so these error messages, sometimes they occur because of internet connection issue. But once they are uploaded, you can just drag and drop those in XDesign and they will be imported. So we will go first with this mates component. Okay, so this one is the SolidWorks assembly. We don't need to import this one. So first we will start with this rectangular base. So to import any component in XDesign, you just need to click on it, drag and drop it, and then it will you will see this dialog box and it will give you some options. So it will give you an option, either you can open it as a new component or you can insert it into the current component. So select this one, and then you need to click on import. So that way now you have imported a component or a part in XDesign, and now it becomes an assembly. Okay. So similarly, now right now this part can be moved anywhere in the 3D space. So just like in real life, if you want to join two components, you will try to add one and then put the other one onto it. So the way to fix a component in XDesign is that you just right click on any component or select this, and you can expand this dialog box, and then there is this option to fix the component. So once you do that, your base part will be fixed. And now, so right now it has just one part. So now we will import another part in it. Same, just click and drag it into the XDesign, and then you can select the insert into the current component. You can enter the number of components you want. So suppose if I type here 2 and insert this component, then there will be two components inserted in this. So these two are free. So one method to move any component is you can click and drag it anywhere in the 3D space. The other method is you can click on component, and then you will see this robot appear. So if you click on any of this arrow and drag it, so the component will move. So to move it precisely, you just need to drag it on the ruler, and then you can see the values. And if you click on any value, then you can enter precise values like 30 mm and more. So that way you can insert more components in it. So we will insert another component also, and connectors. We will insert those also as new components. Yeah, so one method which I told you, that how you can have multiple copies of a component, is that when you are inserting, you enter the number of component you want. And the other method is that, so this end connector, we have just one of it. We want to create another copy of this one. So just press Control on your keyboard. And while pressing the Control, you need to click and drag to create a copy of any component. So that way you can make two copies of a single component. So now, yeah. So this was how you can create an assembly in XDesign. There is another method also. So suppose you want to create something in XDesign as a part. So you just need to select any of the face. So I will just give you an example, that let's make this plane visible. Okay. And I will click on it. I will do some sketch. So let's just create this rectangle. I'm just giving an example. So I'm not worried about the dimensions. And I will just extrude this. And then right now it is not as a part in the X design. So it is actually fixed. So to make it as a part, I will add another feature onto it, so that it will be more clear, like how you can create anything in X design and make it a part. So I will just extrude this also. So now there are these two features. Okay. So I just need to click on the last feature, and then there is this option to make it as a component. So when you click on that, so the sketch which I created and the features, so those all will become a part. So let's suppose I name it as an example. So now this example is also a separate component. So that way, so suppose you create one part and then you make it as a component, then again, so on this plane, again, you can create another sketch, and we will just extrude this one also. And now I will make this one also as a component. and now we have two of these components. Okay, so this is one of the ways. So similarly, you can create n number of components in xdesign, and then it becomes an assembly. So I will just delete these because we are going to work with these parts only. Yeah. So now these all of these parts are moving freely with relative to each other, just like in real world. So if we want to fix anything in real world, we can use glue, we can use nut and bolts, we can use cable ties and other things. So similarly, in XDesign also, we have these tools like glue and stapler pin and other things. We call them as mates. So mates, you can find them in assembly tab, and there we have this option called mates. So when you click on it, a dialog box will appear. Wait, yeah. So a dialog box with title mate will appear. So now it is asking us to select geometry to create a mate. So what does it mean by the geometry? So the geometry means we can either select faces, we can select edges. So these things we can select, and the type of selection we do. So I will just show you an example. So if I select this face, so mates are only applied between two parts. So when I select a face on any part, it becomes translucent. I cannot select any other part of that, other face of that part. So I need to select some other part. So if I select this face, so these two faces are planar faces. So accordingly, I can apply these mates. Coincident. So this coincident mate, what it will do when I apply this, so now this mate will appear in this mates subsection. So what it did is that now coincident mean that these two faces will always be coincident to each other no matter where I move them. So you can see that. Yeah. So I will explain you other mates also in similar fashion. So let me just delete this one. So again, if the other method is that you select one face, then you can press shift to multi-select, and then you can press another face, and then again you will get these options. So we have seen what the coincident mate does. Now let's see what the perpendicular mate does. So when I apply that, then these two faces will always remain perpendicular to each other. So that's how the perpendicular mate and coincident mate works. Let's see another mate. I will select these two, and then there is this another mate called parallel. So you can understand like these mates are so easy to understand. It says parallel, that means now these two faces will always remain parallel. You cannot rotate this part now. So let's see another mate in similar fashion. So now we will see the distance mate. So as the name suggests, you can enter a distance, and then those two faces will always remain at 20 mm apart. And then if you want to edit a mate, just click on it. You will get this edit mate. And then now instead of 20, let's make it 50. So now it is 50 mm above. And then there is this another mate called angle mate. So this angle mate, what it does, you can uh, set an angle between the two faces. So suppose let's make it 30. So now if you see, these two mates are always at 30-degree angle. So whenever you move them, if you see this symbol, that means your mates are not completely resolved. You just need to select on this solve icon, and that icon will appear and your assembly is now updated. So these are the mates which you can apply between two plane surfaces. So what happens if you select two cylindrical surfaces? So suppose I select this surface, which is a cylindrical surface, and another cylindrical surface in this part. Then I have different options. So one of that option is concentric. So as the name suggests, when you click on that, these two holes becomes concentric to each other. So as you can see, so see, when I move this, these two holes are always concentric. And let's see what other option is there. When I select the two circles, two cylindrical surfaces, we have this perpendicular one. So as the name suggests now, so in cylindrical surfaces, what is being, perpendicular? It is the axis. So the axis of that cylindrical surface and axis of this cylindrical surface, they are always perpendicular to each other. And the other option is, which is a little bit interesting, is if you select these two cylindrical surfaces, we have, so the parallel one, the both the axes will become parallel, but this tangent one, when you apply that, so it is more, easy to understand when we apply tangent made between a plane surface and a cylindrical surface. So now if you see, the circle is always tangent to that plane surface. So that is what is being done by that tangent constraint. So all of these you will use according to what you want to achieve with your real product. So yeah, so let's complete this first challenge. So so once we share this file, I want you to recreate what I am doing here, or you play with these parts and explore how assemblies work in XDesign. So first we will make this face and this face and this face coincident. So one of a, I would like to share a tip with you that before applying mates, it is always a good practice that you arrange your parts in a way that will be, approximately the way you want them to be. So I will just move this part here, and I will keep it here. And so I will just show you like what will be the end product. So you can just see this, drag and drop this one, and I will insert it in the current component. Give it a minute because it is an assembly, so it may take some time. So according to the network connection, the time can vary. So let's import this. So in the uh, challenges file that we will share you, it will also have the complete assembly that you need to do. So this is what we need to make with all these parts. Okay. So now this part, I need to arrange it like this one. Okay. So I will just drag this here. Let me move it a little bit further away. And now to rotate a part. So I have shown you that if you want to move something, you just click on the part and then this robot appear and you can move it. So when you select the arrows, you can move it in linear directions. But if you select this arc, then you can rotate it. So that way we can rotate it and move it down and then move it toward this. And so this is the cube. From there you can rearrange your assembly quickly. So we will just do it like this. And now the green parts. So we will just place them close to where they should be. And now from this side also we will place them. And now we need to rotate them so that they look like what we want in the final assembly. So to rotate the part, so if you want to see like whenever you hover over any part in the design tree, you can see they are highlighted in the graphics area. So I know like when I click this, So this part will be highlighted. Now to rotate in the other axis, I will just reorient my view and move it like this. Similarly, I will do with the other brace. Select it, rotate it, and again rotate it. And then we need to move it sideways. Yes. So you can see that in this final assembly, this part and this part, they are on a same level. So that means we need to apply coincident mate. So I will select this face, then press shift and then select this face. So with this multi-select, I get this pop-up menu where I have all the mates which I can apply to these two surfaces. So I will select the coincident one. And now these two planes are in same level. But so what I mentioned when I was explaining the mates that it constrained the degrees of freedom. So right now they will always be in level, but I can move it in two direction. So I cannot move it in the Z direction, but I right now I can move it in X and Y direction. So to constrain that movement, what I will do, I will select this face and I will select this face and then apply coincident mate between them. So what it did that now I can move this part only about X direction only because I have applied these two mate, this mate and this mate, which are removing 2 degrees of freedom, Y and Z, and now it can only move in X direction. But in this one, it is rigidly fixed. So that means we need to apply another mate. So we can see that it is at somewhat distance from each other. So we will apply that distance also. So first, let's apply the same coincident mate to this part also. So I will click this face. So let me do it from the command manager. So in the assembly tab, we will click on mate. And in the geometry set for geometries, we will select this face and this face, and then we will select coincident. So if I press OK, this dialog box will disappear. But if I press, so let me select this and press on coincident and click on apply and continue. So this dialog box will not appear. So if you want to apply many mates in quickly, so you just need to click apply and continue and then you are ready to apply another mate. So I will click on this face and this face and now I will select the distance mate. So what the distance mate does, I can enter exact value like 10 mm, and now the distance between these two faces always be 10 mm. So I will click on apply and continue, and then I will apply distance made between these two faces, and I will enter it as 135. Okay, so now these two faces are rigidly connected to this plate. So so you can see that. So this face will not move because this is coincident and it is coincident with this one. And then we have fixed the distance. So now similarly, we will fix these two also. So again, we will use the mate command to quickly add mates. Select this face, make it coincident, apply and continue. Select this face, enter a distance of 35.5 and now apply and continue. And this face, make it coincident, apply and continue. And similarly, distance between this face and this face and make it 35.5. So if you want to see your part is fixed or not, you can just click on it and see. So right now it is moving in this direction. This part is also moving in this direction. So I can apply a mate between this face and this face, and then that movement will be restricted. So now this one is fixed. So similarly, I can click on this, and make it coincident. And now these both are fixed. So, so, uh, so why we did this? Like in this one, no part is moving. All the parts are fixed together. So this is, so in the left side in this mate section, you can see the mates that you have applied. So this also represents, so suppose if you want to create something big, then you need to break it into smaller parts and then glue everything together. So for that kind of thing, you need to apply mates to constrain all degrees of freedom in any assembly. So now we will go for the challenge 2. So the challenge 2 is the grinder assembly. So now you can save it, and then we will create a new assembly and import these components. So let me just close this one and create a new assembly. So now we will name it as grinder, and always select the collaborative space in which you want to create the assembly. So now let's first see what we are going to actually create. So we are going to create this. Let me just insert it. So instead of inserting the assembly, so if you remember the picture which was there in the PPT, so we are going to create that grinder in it. So instead of ruining the surprise, I think it will be better if I create it step by step. So first we will insert the base. You need to just click and drag it into XDesign and it will open. So first you just upload everything in the 3D drive and then you can quickly import it in XDesign. So first we have imported this base, and let's import other parts also. So let's import the handle. Always make sure that you select this option, insert into current component. Otherwise, if you select the open as new component, it will create a new part. So always make sure that you are selecting insert into current component option and the number of instances according to what you need. So see, when you are importing multiple parts in an assembly, so all of them will always, be present at the origin. So what I do that whenever I import something, I always make them move related to each other so that there is a distance and I can see all the parts that I have inserted. Let's insert the knob. And I will just move it also. And then the machine screw. Okay, yeah, yeah. So if you select open as new component, then it will ask you to save it. So because this current assembly will be closed and the new part will open. So this pop-up dialog box, you can just click on cancel and then import it again. So insert into current component, import. See, why I was saying that you should always, separate all the parts, because I imported something, but I cannot see it. So just click on it and then drag it and then it is visible now. So now the slider, wait, let's see where it is. Yeah, there is a slider and then the last component. Let's see where it is. Yeah, so there is the last component. Yeah. So now we will close this and now we need to assemble everything to make that grinder. Okay. So first thing is that this slider, it will fix into these slots. Okay. So this face and this face, they need to be coincident. Okay. So right now, none of these parts are fixed. So that's why, so if I move this part, the other part will also move. So always fix one part. So let's fix this one, the base. And now I can see that only the slider is moving and the base is fixed. So we have made this coincident with the slider base. And now we will add coincident mate between this face and this slanted face. So with these two mates, I have restricted its motion in uh, Z and X direction. So now it will only move within this slot. So similarly, we will create a copy of this and add that slider in the another slot. So I just need to press Control, click on any part, drag it to make a copy. And we will add coincident made between the slider and the base. And we will make these slanted faces also coincident. And now you can see that this slider fits well in this slot. So now we have both of these sliders. Now we will attach the handle to this handle plate, or we can attach this handle to the slider. So just like real life, first thing we need to do is that we need to put this handle plate on the slider. So I will select the top face of the slider and the bottom face of the handle, and I will make them coincident. So now it is coincident with that. And after putting both of them on top of each other, then we will align the holes. Now to align the holes, I need to select the cylindrical face in the slider and in the plate, and I can make them concentric. So now just like real life, this part is, you know, attached to the slider. Now in real life, we will also make it secure using a screw. So I will add that screw in the slider. So if the direction of the mate is a little bit off, right now it is, it is facing downward. So what you can do, so I will select that mate in the mate subsection, and I can just reverse that orientation. So now it is oriented correctly. But right now it is moving up and down in the hole. So we will just fix that also by making a coincident mate between the nut and the plate. So now this is fixed. Similarly, we can do the same thing for the other slider also. We can make them concentric. And then, so here we do not need to add that coincident mate between the top face and the slider because it is already present with this slider. So we have already restricted its motion in that direction. So we don't need to apply it again. Now we need another screw. So we will just duplicate this and add that in the slider also. And we will add a coincident mate between these two. Now we will attach the handle. So to do that, we will just select these two. We will put the handle on the plate. And now we will make this and this hole coincident. And to secure this, we will add this screw also. So let me just add a concentric mate between them and change the orientation. And I will just make these two faces coincident. So now if we look from this view, if I move this handle, these two sliders will slide in these slots. So now it is representing that in real life how this slider will work. Obviously, there will be friction in real life, but the relative motion of these two slider, it is being simulated in X design. So that's how by applying different mates, you can simulate the real world phenomena. So that was our challenge too. And I think we have covered a lot in this session. And the for challenge 3 and 4, we will be covering that in our future sessions. And I think now we can open the floor for Q&A. Right, Sagar? Okay, so Sagar is not there. So Ishwar, Rishikesh, are there any questions which we need to answer right now?
Yeah, we have some questions.
Yes,
Just a minute.
so yeah.
Just you select more than okay. One of is can you select more than one mate?
Yes, so selecting more than one mate. So when you select two faces, so suppose I select this face and this face, so I can see what kind of mates I need to apply. So if I apply this parallel mate, and then I can apply another mate on these two faces, suppose the distance mate. So since these two mates are, in correlation with each other, so that's how you can apply. But if you apply another mate, suppose I have applied the parallel mate. Now, if I applied this coincident mate, it will be in contradiction of that. Then I can get an error that there is a mate conflict. So when you are representing the real life scenario, these error messages will not be there. So if you are representing the real scenario using the mates, you can apply more than two mates, three mates, but they should represent the real life scenario and they should be compatible with each other.
Okay, another one is what is difference between tangent and concentric mate?
Yeah, so tangent means I will just show you with this nut. So you understand that when you apply concentric mate, the two cylindrical surfaces, their axis will be in. Wait, I will just copy another one and let me fix this one. And now if I make these two concentric, you can see that their axes are aligned with each other. Okay. But if I apply the tangent mate, these two surfaces, sorry, yeah, these two surfaces will always be tangent to each other. Sorry, again. Yeah, so I think, and similarly, if you can apply these tangent mate to with a flat surface, this cylindrical surface will always remain tangent to that flat surface. So you can see, just like a circle. So a tangent to a circle is that it is always, in contact with the circle. So that is the main difference between them. I hope I was able to explain you the difference between those. So these mates, the difference between these mates matter very less. The main thing is that when you see some connection in real life and then you decide like which of these mates can represent that connection, that is more important. So right now you can see that this base is actually its vertical direction is y. So I will just quickly fix that. So you can just make the base float, and I will make this plane appear, and I will add a coincident meet between them. Let me just reverse the direction. And now, yeah, now it is aligned with the z-axis. And when you see these yellow marks, just refresh this and all of those will be go away. If your mates are correct, then it will be resolved.
Yeah, We have covered most of the questions. Now you can go to the concluding remark.
Yeah. So Rishikesh, should we share the files right now or later?
So Sagar sir would guide us regarding this. Earlier we have covered the challenges in the session itself. So that recording was present, but now how we can share, Sagar sir will guide us.
Okay, okay, no problem. So we will share the challenges with everybody later, and these two challenges you can complete. There are two more challenges. For those, we will provide separate video, or maybe we can cover them in future sessions.
I think
So
I'll, I
yeah.
think we do have, or like we do post on community itself also challenges.
Yeah, so you
We
guys,
can
so we
provide
will
them.
be, yeah. So in the Made in 3D dashboard, just beside the X design, you have your community tab, and there in the community we will be posting the challenges, and from there you can access these 3D models. You just need to import them in 3D drive, and then you can uh, use them in assembly in X design. So today we covered how you can create a new assembly, how you can import a part in it, and how you can add mates to simulate the real world phenomena. I hope I was able to provide useful insight to everyone. And if you have any questions, any queries, you can connect to any of our team members. We will be happy to share and help you. Thank you all for joining this webinar, and see you in the next one.